All right, good morning, everyone. So I thought now was a good time to drop a group assignment on top of you before we start moving on to new things. So here's a group assignment. So here we have three particles. We have Q1 and Q2, which are along the y-axis. Each one is a distance of d away from the origin, where d in this case is 17 centimeters. And each one of them has a charge of twice the fundamental charge. So if you want, you can think about this as helium, for example. Or an alpha particle, that would work as well. Then we're going to put a third charge, Q3 here, which has a charge of 4 times the fundamental charge, along the x-axis. And we're going to move it only along the x-axis between x is equal to 0 out to some distance out here, like 5 meters away. So we want to know then, what value of x will the magnitude of the electric force on the third particle be its minimum? That's going to occur actually twice, but between 0 and 5, it only occurs once. Where is it its maximum? And then what is the minimum value of that force? And then what is the maximum value of that force? Okay. So let's think about what's happening here. So basically what's happening is I have this one is applying a force onto him in this direction, because they're both positive charges, so it's going to be a repulsive force this way. This one's going to apply a force onto him in this direction, which will also be a repulsive force since they're positive, which means that I have one vector pointing off in this direction, one vector pointing off in this direction. But what can you tell me about the vertical components of this force? It's 0. It's 0, right? The sum of the two vertical pieces are exactly the same, right? So this one is this way, this one is this way. But since they're both the same distance, they're both the same magnitude of charges. What that means then is that the vertical components of the force is equal and opposite, so that's just going to cancel out. Which means the only thing I'm going to be left with then is the horizontal force along any x-axis. So this is going to be the direction of the force. Now, other things to note is, depending on where this charge is, the angle that this thing makes is also going to be dependent on where it is. So what that means is if I move this charge to this location here, I'm going to draw this guy to be here, so I have this angle between the hypotenuse and the x-axis. But when it's out here, I now have a more shallower angle. So the farther it gets away, the more the shallow the angle becomes. Which means that the angle depends on the location of where it is. So basically, when you're writing out the sum of the forces, here we only care about the horizontal component, which means we're going to take cosine and angle into account. But that angle is position dependent, which means I have to rewrite the angle in terms of the position to finally get this thing only in terms of the position and where it is along the x-axis. Then, as we did yesterday, if I want to find a maximum amount of force, what do I have to do? I have to take a derivative, in this case, with respect to the position, set that equal to 0, and then solve for the position, and then do it that way. So that's it. Let you guys start talking about this. So I was going to give you like 15, 20 minutes, and then turns out the entire class time, but we'll see how it works out. So, what's up, Omar? Yeah. So all you can say for A, you can say, well, when it's sitting here, the vertical components again cancel. There's no horizontal component, so it's 0. So mathematically, you don't have to do anything mathematically. Like I say, well, at least the force is going to be 0 when it's sitting directly at the origin. So you know, x min has to be 0, and f min has to be 0 as well. Yeah, you can absolutely do that conceptually. The other part's a little more complicated. So you do have to write out you do have to do a derivative in that case. Not quite. Not quite. So start off with the free body diagrams, and then from the free body diagrams, write out some of the forces on it, and then from there, write out the force, and then from there, take its derivative, set it equal to 0, and then solve for x. And let me know if you need help with the cosine angle parts. So one thing I should mention, expect to see a lot of minimization problems, minimization, maximization problems. So derivatives, things like that.
This is like not sound.
Yeah, because each one is going to be a cosine function.
The expression of the sum of
Yep. Yep. And then the only thing you know is that F1 is actually equal to F2.
Yeah.
So it's just going to be twice of F1 cosine of it. Yep. You don't need the MA part. We're not looking at the acceleration, we're just looking at sum of forces. So, well, not equal to 0, just equal to whatever that is. So we're only looking at the left-hand side. So we're only doing the sum of forces binary, not equal to MA. So just sum of forces. Because the only direction is equal to 0 is in the y direction. What's up? What's this? Well, remember the force is Q1, Q2 over the distance r squared. So that's a correct expression if you say twice of F cosine of theta, but not twice of Q, because F is not equal to Q. Correct. So remember Coulomb's law. So Coulomb's law is again, K times Q1, Q2 over R squared.
Yeah.
So that's what happens. There's a mark. Okay, just a number. It's a 9 times 10 to the meter squared.
Is this a clear? Two.
Well, we need times cosine because we're only looking for the horizontal piece. Okay. Because the vertical piece is, so if we look at this force and this force, and this vertical piece cancel, which means we only want the horizontal piece.
Oh, so you have to take the cosine.
Exactly. So define an angle there, call that angle theta, and then take only cosine of that. Yep. What's up?
Make this into an expression. Right?
Correct.
Okay, so
Yeah.
Okay.
Okay. Sounds good. So the thing I'll tell you is, if you look at this angle here versus this angle here, how is this angle here related to this angle? Interesting. So use the angle on this side, not the angle on this side. Okay. So that way you can use the geometry to bring. And figure out. Okay. Oh, so let's draw.
Because then it's not a factor.
Good, so let's draw the charge there. So let's think about the forces.
So there's a force wanting to push forward each way.
So I want to push this one. is the size of those equals?
Oh, because it equals, if you're squeezed together, you're not gonna. It would be just like, yeah.
Yeah, exactly. Exactly. So when I put my keys on here, exactly. So here, the table's putting keys on in this direction. Exactly. Gravity's in this direction. But those two forces are equal and opposite. Okay. So every result in no force. Got it. Exactly. Okay. Good. Okay. And then here. So first of all, what you need to do is write out both d squared and cosine theta in terms of x, right? Because what I want to do is take the derivative with respect to x, but d squared, which is this distance here, which is the hypotenuse of this triangle, and this angle here, depend both on x. So you have to now rewrite cosine theta and d squared as a function of x. So do some geometry. How are we doing? Sure. So remember x is defined here as only the distance from the origin to this location. But in Coulomb's law, what I care about is the distance between the two charges. Which means the distance between the two charges is this distance, not this distance. Right? But I know this distance here is simply this distance squared plus this distance squared squared root. The Pythagorean theorem, right? So that means when you have the over squared here, it's not just x squared, but it's x squared plus b. Right? And then the other thing, then you have to rewrite the cosine. Okay. What's up, Laura?
That R squared on this longest. That change.
Well, as x gets bigger, r squared gets bigger. Well, exactly like so r squared is just x squared plus.
That's exactly what I guess would you have to like find the rate of how.
Oh, well, that'll happen as you take the derivative. So when you take the derivative, that'll automatically pop up.
Okay, so I don't need to so okay, this x squared equation here, I just put these here.
Well, this r squared here is then going to become x squared plus b.
Yeah, that's what I was sorry.
Exactly. Exactly. Yes. That's right. So x will naturally show up inside of there when you take the derivative. And then the other thing you need to do is rewrite that cosine in terms of x as well.
Okay.
Because cosine also is dependent on x.
Yeah.
It will also have a rate of change as x is changing.
Okay.
That's right. So now you got r squared in terms of x squared, and now you just need to rewrite cosine in terms of x.
Cosine. That. The thing is, cosine is the thing.
Well, think about the definition of cosine. So cosine is the adjacent over
What did you say?
correct.
Radius.
The adjacent side.
Yeah,
Same
radius.
rate.
Not quite the same rate. Right, because the hypotenuse goes as the square root of x squared plus b squared. But the adjacent side is only x.
So okay, I have an idea. So cosine is 17.
So adjacent side, which is x.
Yeah.
Divided by the hypotenuse, which is the square root of x squared.
Yeah, that's what I was thinking. Square root of that.
Plus x squared. Yep. Exactly. Now put that in here. So finally, you're going to get an x in the numerator, and this is going to be x squared plus b squared times the square root of x squared plus d squared. But that's the same thing as x squared plus b squared raised to the 30th power. What's up?
I don't know where to find.
Oh, because here you're saying the sum of these two is this, which is correct, but I want only the horizontal piece of the sum of those two. Right?
What about
Which
my
means-
theta?
Oh, your theta is going to go here.
Oh, okay.
Yeah.
Okay, I had it.
Got it. Well, you could do it that way, but then it would be the sine of the angle instead of the cosine.
Okay, I was wondering why this one was way with that angle.
Gotcha. Yeah, but that one, no, I didn't. didn't see where you kind of drew it over. Yeah. So again, if I draw it, so if I'm thinking about this particle here, I got this force this way, this force this way. But I'm thinking about this angle here, which is the same as this angle here.
Okay.
And I mean, I could define it as u data in terms of this angle, but then I'd have to sine instead.
You'll get my good.
And remember, cosine is adjacent over hypotenuse. What's up, Omar?
So this would be,
So it's right now. Yeah.
I was making sure about that. So x equals 0.
We got cosine of 1/3 times x. The x comes from the cosine
Yeah.
divided by x squared plus d squared to 5. And that's your entire. You doing okay? Okay. Good. Yes.
Oh, you're already plugged in the E.
Yes, so you got 4. By 4.
You're supposed to.
Well, be careful because I'm taking the 2e times the
You're also
4
supposed to do
eight.
that twice.
Because I'm looking at the force between Q1 and Q3, not Q2. Oh, that's okay. Perfect. So that's. Oh, I see. So you can't take the 4 from 4 pi epsilon. Okay. No, we're good. Okay. Oh, what you have is that. Yes. Yeah. So now take this expression that you have here and take the derivative off. So then I'm going to take the derivative of 4e squared x divided by pi. Take the derivative of that, which is actually x instead of
I think that equals 30.
correct. So anything that's a constant, you can just divide both sides by. So you get rid of the 4 squared or pi epsilon.
That's what we get.
X derivative of x over x squared plus. Only 3 has it. Equals. Now, since all that's equal to 0, you can cancel out all those constants. That we don't. Exactly. Because it's equal to 0, I can divide through by those constants. And it doesn't.
All right.
But I got it. What's up?
Do the theta part.
So the theta part is, so notice that, for example, if I'm working with this force here, I have this portion of the angle is cosine. So this angle here is identical to this angle here. So using this angle, I can then use this angle here because I know the adjacent side, that's simply x, and I know the hypotenuse, that's the r squared. So that means cosine is then just x divided by the square root of x squared plus d squared.
Am I ever finding this like that?
Right, so the 2 and the k, since it's equal to 0, I can just divide those through. So the q's, the k's, and the 2, since it's all equal to 0, remember I take the derivative and set it equal to 0.
Yeah.
So I can just get rid of those terms.
What you just did.
Well, that's one way to do it.
Okay,
There's an easier way.
okay, I did not use the.
You're fine. So you're using what's known as the quotient rule. I always do everything with the product rule, which makes it much easier.
Okay, so why did you, how did you set that equal to 0?
Because remember, I'm trying to maximize that function.
Yeah.
So whenever I take a derivative and I set that equal, the derivative equals to 0, that's when I maximize my function in respect to x. So here, we're just saying we're going to take that derivative, set it equal to 0. But since I have all these 2k's and pi's and all this different stuff, it's basically in there. Since all of it's equal to 0, I can divide by all those constants and it doesn't do anything.
It does not do anything.
No, because it's 2 and K and Q and all that stuff don't depend on X. So I'm not taking the derivative with respect to
Thank
that.
you.
Okay.
I'm trying not to think
So you still have an X on top though, right?
Correct.
Don't,
So
yeah,
you could- so
come to the
you
front
still
and
have
then just
one
pair
more
for
second,
one.
Quotient rule, because you could just say that.
So
this
we're
is
gonna
the-
Exactly.
3 halves.
So this is one of my problems with math is they teach the quotient rule, which is basically pointless because everything is a product. And there's no point to ever remember the quotient rule because it's the most useless thing ever. So
Yeah,
everything is
it's
product.
right. We did a whole song like this. So, quotient rule.
It's an overly complicated thing that you don't have to.
Really, is that always?
Always. Because y divided by x is y times x to the minus 1.
One I did.
Everything is a product. Just like addition and subtraction is division.
Yeah.
I'm just adding a negative number. So multiplication and division are exactly the same thing,
That's the.
as well as addition and subtraction are also exactly the same.
Yeah, this thing is pretty disgusting.
Yes. So it's much easier to use the product rule. We can go through that. What's up?
Am I doing this right? Or am I totally wrong?
Well, no. So we need to multiply this by cosine. So put the cosine sign over here.
Okay.
Minus the top times the bottom. But for the derivative of the bottom, we have to use.
Good. And all of that is just equal to the force. So you're just writing force is equal to.
Okay.
Correct. So now what you want to do is take the derivative of
With
this
respect to that.
with respect to x. That's right. Now, be careful.
I
So
think I
r
got
squared
this.
is this thing.
I'm just like, just replace that with that.
Yes,
And
with a
get rid of the square- with the square root.
Exactly. But cosine also depends on x as you have right here.
Good.
So basically, I'm gonna get this guy squared times this guy, so it's gonna give me a 3 halves. So basically
I can put it in
this,
my calculator.
so get rid of r squared. Put a parentheses around the square roots and put a square on it. So we know all that's
So you
squared.
just put that in as R squared, like.
Yes,
Okay.
exactly. And now I'm gonna replace this term here, the cosine with this.
Okay, put that inside.
Exactly.
All
So
right.
you can do that on the next line.
And
so
then
that
take
we
the
know.
derivative.
And then eventually you can.
Okay.
What's that?
But we probably need it square root of twice.
You're confused too much. So why do you have Q1 and plus?
So.
Well, Q1 is equal to Q, right? So that's just gonna be 2 times Q. Q.
Like what you call it.
We solve for x by setting the derivative has to equal 0.
Oh.
Beautiful. Good. So that's your force. Now what you want to do is take the derivative of that with respect to x and that equals 0.
So that's what that. Well, R squared.
All right, let me teach you guys how to actually do a derivative because I know math department doesn't do a very good job of this. So remember that anytime I have something divided by something else, that's the same thing as something multiplied by something else to the negative value, right? Which means the quotient rule is probably the most useless thing you can ever learn. Everything is actually just product rule, right? So what you have here is you have to think of derivative with respect to x of x times x squared plus d squared all raised to the minus 3 halves power, right? And what I want to do is set that guy equal to 0. So here, since I've written it this way, I can actually do it as a product rule, right? So I'm going to take a derivative of the first one times the second plus the first times the derivative of the second, right? This is a product rule. So let's do that. So that means that I take the derivative first, which is x squared. So I can have x squared plus d squared raised to the minus 3 halves power, plus the first, which is x times the derivative of the second, which becomes a negative 3 halves, times x squared plus d squared raised to the minus 5 halves, all times the derivative of the inside, which is simply 2 times x, which is all then equal to 0. Right? Okay with this? Now, let's rewrite this out. So this is 1 over x squared plus d squared to the 3 halves power. This minus sign here, and this 2 cancels this 2, so this is going to be minus 3 times x, all divided by then. Going to get an x squared plus d squared raised to the 5 halves power is equal to 0. Right? Whoops, x squared. Because I have this squared here, this x. Now from here, I found a common denominator. Common denominator is simply this term, right, with the 5 halves. So I'm gonna multiply top and bottom of that one by this guy. So this now is gonna become x squared plus d squared minus 3 times x squared, all divided by x squared plus d squared, all raised to the 5 halves power, is equal to 0, right? Okay? Now notice this term here cancels out with one of those. And since this is equal to 0, all I have to do is multiply this side over here, which cancels the whole entire denominator, so I don't even care what the denominator is, since it just goes away. So finally, what I'm left with is that what d squared is equal to 2 times x squared, which means x is equal to 0 squared.
Oh, man, just solve this in 10 seconds.
What's up, Terrence? What's up? Well, we don't have to find just the angle. We want cosine of the angle, so you can actually just leave it like that. You can go that far if you want to. But now basically all you want to do is, oh, be careful here. Because this isn't cosine, so careful here. So you have cosine, angle is equal to the arc cosine of x over d. It's over d, not d squared. Remember, it's hypotenuse, not hypotenuse squared. Here in the square there. So be careful here. So what you're doing is you're taking a cosine of an arc cosine of x over d. Because I have to use this whole entire arc cosine into here as well, because that's part of the angle. That make sense?
Oh, so cosine.
Of an arc cosine. Well, cosine of an arc cosine is just the arc. So that's why you just stay with the line you had before that, where you said cosine of the angle was equal to.
Yeah, I don't like that. You factor this out, which would make it useless.
Exactly.
And then this is just, you factor this guy out, and then this guy becomes that out there.
Yes.
Yeah.
It's exactly what I have out there in an easier way.
Yeah.
Yeah.
That's nice.
So the answer to all that is never use the quote. So basically, what's up?
So I got a couple questions.
Sure.
I know that we lost. So first, when you start getting the derivative, what did you use this term?
That comes from, so first, you have to see where it comes from, the forces. So to understand that, you need to first do all the forces onto that particle first, and you'll see where that comes from.
And I get that with the Coulomb's law.
Yes,
Okay.
correct. And be careful, that should be 1 over r squared, not 1 over r.
That's correct. It should be what, sorry?
So that's kq1 q2 over r squared, not just r. Q2 all over r squared, not just r. There you go. Because the way I have it right here is you just have it written as r, not r squared.
Okay, thank you.
What was the rest of the problem?
Oh, so there's the problem now is just take this, plug it back into the force, and then find the maximum amount of force. So
Oh, you just plug it in correctly.
Yeah. you're right there. What's that? The entire. Yeah. It should be the minus 3 halves minus half, right? Because you already have an x squared plus b squared here, and you're picking up a square root of x squared plus b squared. Well, you don't have, you have the denominator, right? Because it's k q1 q2 over r squared.
Oh.
And r squared is x squared plus b squared. And then you have another r from here, which is an x squared pair. No, that's r, not r squared. Right, because think about the dimensions. If this is a meter squared, what's the dimension? It's a meter squared, square rooted, which is a meter. So this doesn't unit wise. What's up, guys? Okay, so first of all, your r squared is not good. Because what you have here is r, not r squared. So you should square that. Good, so that's our first thing. Now, the other thing is, remember, as I said in the beginning, the angle depends on x as well. Which means the next thing you have to do is rewrite cosine in terms of the geometry. So x and r. So if I look at this angle here. Yeah, well, it's just x over r, not x over r. X divided by r, but r is the same thing as the square root of x squared plus b squared. Yeah, because r is just a hypotenuse. Yes, but with a square root this time. So that brings k, q1, q2 times x. Well, remember, one is square root and the other one is not. Because this one is over r squared with this one. So now, when I multiply those together, that's what gives me the difference. Correct. So that brings that to x squared plus b squared. Yeah, that's f1, 2 or f, well, it's f1, 3 or f. Well, again, we're summing the two together, which means it's twice of that. So ultimately, sum. That's right. So the only thing that happens is you pick up a factor of 2 because the 2 are exactly. Exactly. Oh,
Real quick. Would this be the answer?
Right, and then. Well, be careful, that's an x squared in the square.
Oh, yeah.
So that becomes a, so it's gonna be a d squared over 2. So you have a d squared over 2 plus d squared, but what's d squared over 2 plus d squared? Almost. So half of d squared plus d squared. So it's on 2, because I have 2, it goes d squared plus d squared.
Oh, yeah.
But I have half of d squared plus d squared.
Why is it 1 over?
So what's 1/2 plus 1? Yeah. So it's 3 halves. D squared. What's up? Oh, remember, yeah, so you're just writing out the forces. Square. Good. So now rewrites what R1, 2 is, or sorry, what R31 is, and what R2 are, and in terms of the geometry. What's up?
I think I have the derivative, so if I just don't want to get too far, I have to, I just pulled those out.
Yeah, and since the derivative is equal to 0, you can just cancel those.
Okay, and then just solve for that.
Yeah, I think that.
Yep.
Multiply by the negative.
Exactly.
Okay.
Yep. We do a product rule, not
Yep.
quotient rule.
Okay.
So wait a minute. What's up?
Yeah.
Well, absolutely. Well, you already had F net. So what are you trying to do? So you're now you just need to find the maximum force, right? So we're doing right. So the maximum force is going to be when I plug this back into F net. Because that's the X which extremizes F. So if I want to know what the extremization of F is, I just plug that X back in to find out what is the extremizer. We plug it in directly into this. So this is where you start before you figure it out. So now take that X and simply plug it. In this case, we have to keep the constants because it's part of F itself. So we're not setting out equal to 0, we're just finding out what F is. Yeah. So if I want to know the maximum amount of force on it, I'd take whatever X is that maximum, plug that back into the force, and then that's the force. Does that make sense? Yeah. Oh, so all I'm doing is find a common denominator, which is 1 over x squared plus b squared to the fifth. that's making this curve color. Which means I'm gonna multiply top and bottom of that by x squared. Because if I have x squared plus b squared raised to the 3 halves, get that to x squared plus b squared raised to the 5 halves. And I just multiply it by a 2 over 2. But 2 over 2 is the same thing. So multiplying top of the bottom by x squared. You combine the denominator. So basically, this term here is now going to bring our x squared plus b squared over x squared plus b squared. Well, since it's equal to 0, when you take the derivative, k and q1 all go here. Well, that's a 3 halves here. With x squared plus b squared raised to the first power times an x squared plus b squared raised to the half power, or 1/2 power, which makes it all.
If you break it, that's square root of x plus
Well, here. So remember, cosine is adjacent over hypotenuse. The way you have it, you have it as a tangent. Actually, you have a cotangent. So that should be x over r, not x over c. That's where that's where. What's up?
Is math correct? So this,
So 3 halves that, and you have the b over there, and then we take a 3 halves power. This becomes a cubed, right?
Yeah.
That's where you're gonna cancel.
oh, I should not know. Yeah,
Okay.
I realize it should be functional, so I keep this whole thing instead of just the.
Oh, gotcha. Yeah, no, so the 3 halves stays to the 3 halves power.
This thing, because it's like, you take this by this, right?
Yeah, so the 3 over 2. Yes, it would be with them. So it would be 3 halves to the 3 halves power times d. And then that d cubed would cancel with the 1 on top, make it a d squared. What's up?
So what happens to the d when you take the derivative of the inside of that?
Oh, and d is just a constant, so
So 0.
just 0.
Okay.
So that means the derivative inside is just 2x.
Okay. And you multiply by the first part.
Multiplied by the first part, which is just x, not x squared.
Oh, I just.
Be careful. So
I thought I
that x
multiplied
wasn't
that x.
there. That x came from that term.
Oh.
Right, so get rid of that x
So
there.
there shouldn't have been.
Correct.
I just multiplied that by that. That's bigger.
Gotcha. But no, this one came from this.
So you plug that, that's what the sign of it was. And you
Right.
just plug that in.
Exactly.
Okay.
So that x on top came from the cosine.
Okay, that makes sense.
What's up? What are I doing? Well, I don't, what are we doing? So is this just the force?
Yeah.
Then it's just a constant. Yeah. And you know, Q1 is equal to 2e, and then you know Q3 is equal to 4e, so that's going to be k times 8e squared.
So, well, you know that.
Right, with respect to x, because I want to extremize it with respect to position. Because the question was, where is the force the maximum? So if I want to know where the force is maximum, then I just take the derivative of the force with respect to position. Set that equal to 0 and then find position. That's the same thing. Exactly. Just calc 1.
Where's the answer? What wasn't there?
Oh God. Where do I go?
Yeah.
Something ridiculously small. 4.91 times 10 to the minus
Oh, I.
26. Oh, okay. So at this stage, you just dump it in over that.
Yeah, what? Okay, he's just.
So D is 17 centimeters, which is 0.17. E is 1.602 times 10 to the minus 19. You have that squared, and then you got K, which is 9 times 10 to the 9th. So it's a small. Okay.
Yeah, I'm just plugging the quiz. Less than way off and then.
Oh, okay. So you did design them. So first of all, get rid of that question. Because that is code. So don't get rid of everything. Because what you're saying is you got cosine in that, but that is. Remember?
But I thought it was square.
Well, no, so it's remember it's opposite over adjacent. Or sorry, adjacent over adjacent.
Or, oh, well, no, I was thinking over here, actually, somewhere here, actually. I thought it was square.
Okay.
Exactly.
And then same thing when you come back here, get rid of that. Because you're not taking cosine of that is.
Okay.
And then now you should be.
Okay.
So now you got
Was it-
that, and now you can put that side out. This, but again, now you're just getting rid of that.
Okay, so I've already got my numbers here, I was just.
Right, you were just saying,
Okay,
oh,
so
I'm
that's
cosine of all that, but it's not.
Yeah.
All of that is, that is.
Yes. And then I think, wait, what?
Exactly 11 times 10 to the negative 31st.
What's that?
9.11 times 10 to the negative 31st.
Well, that's the mass of E, that's not the
Oh,
charge.
that's the mass.
Yeah, the charge of E is that. So 1.602 times 10 to the minus 19.
So whenever you get the same denominator, you multiply it by the bottom of both sides.
So you just multiplying the same thing top and bottom on the second term. So,
Yeah, the Q1 is what?
This way one day. Sorry.
well, you already have the net force, right? So you don't need to do anything else. So basically, right, so C and D or all of C, whatever, yeah, C and D. All you're doing is you're taking your results from A and B and plugging those into the net force that you're already using.
So.
Yeah. So this is your net force. And now from there, all you're doing is taking your X max, plugging it in here, and taking your X min and plugging it in there, and that's it. So X min is equal to 0. So you have 0 on top here, the whole thing is 0. And then take this and plug it into X into this, and then I'll just multiply it.
Use the final question.
Well, be careful. So remember the 3 was to the 2 halves power.
Oh.
Because that's a 3 over 2 all raised to the 3 halves power. And then 2 from there. So basically you have.
You have square root of 8, right?
Let's see, so let's think about this. So you have a, so I have 2 over 3 over 2 to the 3 halves. So if I move the 2 to the top, so that's gonna be 2 times 2 to the 3 halves, but 2 times 2 to the 3 halves is the same thing as 2 to the 5 halves. Divided by 3 to the 3 halves. So your prefactor, which is out front. So your prefactor is basically what? 2 times 2 to the 3 halves divided by 3 to the 3 halves, which is the same thing as 2 to the 5 halves divided by 3 to the 3 halves times all your other stuff. So I think your prefactor is just all right.
Okay.
And then everything else will be fine.
Where'd you get that 2 from?
The 2 came from the fact that you have twice the size of the force, remember?
Oh, yeah.
So if you go back to what you wrote originally, you had that F was equal to 2 times K times Q1, Q2, or Q3 actually, times X divided by square roots, or sorry, X squared plus B squared raised to the 3 halves. So, but also remember that Q1 is equal to twice of B, and then Q2 is equal
Yeah,
to
so you have just
4 times E. So this is going to be 16 E squared times K times X divided by 3 halves D squared to the 3 halves X. D over square root of 2.
I might as well just plug in the numbers like that.
You can do it that way, so we don't have to worry about reducing everything so much, but yeah. 3 halves So you can just plug it in that way if you want to, but yeah, so this is your maximum amount. Doing okay? Doing okay?
Yeah, I think I'm just trying. So multiply this by that, not that.
So let me get rid of it. We took the derivative of that, and we take the derivative of the first one.
Okay, so that's big one.
That's right. So get rid of that X there.
I think I just took the two off because I had the rest of it.
Oh, yeah, but
Think
remember,
about
we
it.
don't have to. Yeah, square that. So get rid of that X on top there. Better, okay. And let's see what happens. So you get a 3/2. Yeah, so that 2 is gonna cancel that 2.
Yeah.
And again, so over here, get rid of.
What?
Good. And then this term here, so again, you have a, so you have the 3/2 from here. That's canceling out this 2.
I
So
just
that's
put it down there.
okay, well, you already got rid of that 2 from there, so
Oh,
this,
so that's just a 3.
well, no, the 3's on top.
4.9.
So that 2 on top should be a 3.
Oh,
There you go, good. So now we want to have common denominator, which is this guy and this guy. So to get this guy to look like this guy, multiply top amount of this by x squared plus d squared. Okay, so now what I'm gonna get is I'm gonna get an x squared plus d squared minus 3x squared, all divided by x squared plus c squared raised to the 5th power. Or 5
oh,
power.
it's multiplied by x squared plus x squared.
Correct.
Yeah, that makes sense.
Exactly.
Oh,
Exactly. The bottom is this.
I'm just trying to figure out how. We didn't win wrong.
Oh, okay, so now all I'm doing is I'm taking this solution, d over square root of 2, and plugging that back into this expression.
Right, but then when you simplify it. it's like,
Oh, okay.
So,
So good, so good. So I'm working with this. So now all I'm doing is I'm rewriting x squared here as was doing that. Right, so this is gonna be the same thing as c divided by square root of 2. So let's do the whole thing. Okay, so let's rewrite this here. So I keep 2 okay. And Q1, Q3.
right, and that's the.
Yeah. They're both moderated,
Right.
times x, which is b divided by square root of 2.
Times X.
Right, because you have that x here. So I'm just rewriting the numerator.
Did that X come from?
The maximization.
Okay.
So that's b divided by square root. Because right now what I'm doing is I'm just finding what the max force is, but the max force is evaluated at x equals x. Right, that's it. No.
Hang on.
Okay. So what we did is we found the position that maximized. Right, that was the point. So now if I want to know, well, what is then the corresponding maximum force? Then all I have to do then is evaluate the force area at the location where I set the maximum force.
Wouldn't that be underneath? The location, because location depends on X. If there is an X.
Right, but we already found that X is.
Right, so that is R.
Well, R is.
Well, you use it to get R.
Correct.
So why is there an X?
In the numerator, it comes. Your cosine. So remember, this is your cosine here. It's your cosine.
Oh, you're.
I'm going to all together.
Okay.
That whole line.
Okay.
So-
Well, that must be working for you, because I was trying to do the separate.
And I'm divided by- and I'm gonna put in X
I'm so crazy.
I was going though.
Okay. Yeah, see, very intuitive for you. We put together how much.
Yeah, they're keeping.
I was trying to hear anything.
No, and it makes sense, yeah, to do it that way. I'm trying to do it separately.
Right, so in that case, then you got four thirds, you gotta worry about everybody comes in the rate. So if I didn't factor them together, what I would have then would be this product.
Oh, really?
So-
Give me more than a cake.
I would have this So that means now I have. Now when I say president. But I can say it's full. So now I have-
It saved my life. But I'm glad I have some of your answers.
I know that's-
So I'm like, oh, there's, you like, you throw the answer in there. I did, yeah. But don't trust me, I might come back. I don't know about that, probably not.
Oh, yeah, they're fine, yeah, so you know, Q3 is equal to 4E, you know, Q1 is equal to 2E.
Oh, where's Q or each of people?
Well, Q2, well, okay, so this is, so let me ask you a question, so scroll. So here, you're fine, so you have this guy plus this guy, this guy plus this guy, and then you went from here to here, right? How do you go from here to here?
Terms.
Uh-huh.
Put these together, but one of these is in Q2.
Right, so one should be Q2, but you know, Q1 and Q2 are the same.
Okay.
Right, which means that you're missing a factor of 2 here. Because I have this guy plus this guy, but this guy and this guy are the same, which means I have 2 factors of that, which means there should be a factor of 2.
Okay, so there will be, there will be a 2 multiplication.
Correct.
So I use,
So you need a multiplication of 2.
that would be.
Yes.
Okay, can I calculator have the number, so it's up.
Yes.
By that, by 2, and that's one.
Exactly.
That makes sense.
So it's basically just saying, well, I have, you know, F1 cosine of theta plus F2 cosine of theta, but F1 is equal to F2, so that's the same thing as twice of F1 times cosine.
So I was like confused that you were talking about cosines and stuff, and it was like, well, I don't give it any apple.
Well, the cosine term comes from the fact that the vertical pieces of the force cancel. So this was something we talked about before, yourself and Johan doing it.
I missed that bus. I think I was so tired.
So since the vertical portions cancel, that means only the horizontal piece